Hi, everybody. This is Slava Kurilyak at Produvia. I am super excited to do this live stream and discuss how artificial intelligence is changing the world. I decided to create this live stream because I noticed there were many questions that can be addressed, many questions that require some explanation in order for individuals and companies around the world to use AI technology. And before I get started, I just want to do a quick technical check just to make sure everything is working as expected. If you are joining this live stream, please leave a comment of who you are, where you're from, and I say hi to you. This live stream will be used to answer some of the most common questions that I noticed from individuals who are thinking about leveraging AI to solve problems. This live stream is meant to be educational, so if you are an individual who has an interest in AI technologies, or you are a professional already using machine learning and deep learning models, then you have come to the right place. I would love to share with you the first question that I decided to address in this live stream. And this question comes from Bavin on Quora. He asks, does programming require intelligence? Great question, Bavin. Language learning is a skill, and this skill is something that we learn over time. Spoken language like English or programming language like Python. Now, intelligence is the ability to apply skills. And so programming as the result does require intelligence. The next question I have from the community is data science a dying field? And will AI or machine learning eventually replace it? Yash Raj on Quora asks, data science will continue to evolve. Data science is an extension of the classical programming paradigm. And so AI will not replace data science. AI and machine learning will be tandem to data science. In other words, data science will continue to evolve and become more complex over time, as will AI and machine learning. And both industries are very important to learn, very critical for companies to use in order for them to derive value from these technologies. It looks like we have individuals who are joining this live stream. I want to say hi to Rael from Vancouver. She's joining from YouTube. So as I've mentioned, if you are joining this live stream, feel free to leave a comment, and I am more than happy to say hi to you and, more importantly, address your questions during the live stream. Coming back to the next question that I would like to address from the community is the question of, are resnets useful in domains other than computer vision and speech, such as ranking and NLP? Yan Jian on Quora asks this question. It's a great question. We're diving a little bit more into the technical aspects of AI. Nonetheless, let's get into it. ResNet is a very unique type of an algorithm. ResNet is a abbreviation for residual networks, hence the name ResNet. And this is a convolutional neural network, often referred to as a CNN. ResNets are commonly used today to address a variety of different problems. The two most common types of domains where ResNets are being used are computer vision and methodology. Computer vision examples of resnets are image classification, object segmentation. We have instance segmentation, activity recognition, all of the different types of data that require the use of imagery or videos. They are well suited for those types of problems. So resnets are amazing algorithms, and at the moment they're primarily being used for solving visual data problems. Having said that, resnets have a characteristic, there's a variety of different methods, and these methods also allow practitioners to use resnets in other domains, less commonly used domains. One great example is natural language processing. I'll share with you 3 ways that you can use ResNet to solve NLP for short types of problems. The first being we can solve problems that are related to language modeling. The second is we can solve multimodal deep learning type of problems. And the third being we can answer common questions. We do what is called question answering type of models. Now, resnets can also be used in other domains beyond NLP. And one great example of that is music, where we can solve song cover identification. We can solve music classification type of problems, or even music information retrieval. Now, I've mentioned to you how we can use a ResNet to solve NLP, how we can use ResNet to solve music. We can also use it in other ways as well. Keep in mind that ResNet is not a unique architecture. This is an architecture that can be used in different domains. And the other examples that come to my mind are graphs and adversarial type of problems. So graphs are what you consider to be the problems of learning to rank, graph learning, or physics-informed machine learning. These are 3 examples of how you can use ResNets to solve graph problems. The last example I wanted to mention is the idea of solving adversarial type of problems. Adversarial problems include adversarial defense and adversarial attacks. And these are very specific examples, but I hope it gives you a glimpse of how you can use ResNets if you were to dive more into them. And again, ResNets are a type of a convolutional neural network, an architecture very commonly used to solve imagery problems, but they can be used to solve language problems, music problems, or problems where there is an attacker or a defender, also known as adversarial problems. Hopefully this gives individuals an opportunity to better understand that ResNets have their various use cases. Let me see what other questions that we can pick from the community that are quite useful. Let me choose one question, and hopefully it comes up on this particular live stream. I will now type it into the caption below so everyone will see. And the question is, will AI automate data science and machine learning jobs? And this was a question that was posed by Amrit on Quora. All right, hopefully everyone can see this particular question. Will AI automate data science and machine learning jobs? Amrit, this is definitely possible. The concept of AI or machine learning is simply the concept of how you leverage data to automate tasks. Now, within the AI community, there is a powerful concept called automated machine learning, and more recently, automated data science. Now, both concepts are related. Data science aims to solve questions of data, rather address questions of data, solve problems related to data. And machine learning aims to address questions related to how you use data to come up with some sort of a prediction or classification. And both of those domains are actually being automated as we speak. And this is the context that I described, the idea of automated machine learning or automated data science. Both within the AI community, extremely powerful because they allow data scientists and machine learning practitioners to use tools and save themselves time. If an individual is using an automated ML or automated DS technique, they are performing something that would take them longer to perform, and now the tool is helping them. It's augmenting their own skills and helping them derive the insight or answer faster than if they did not use automated ML or automated DS. Both techniques are extremely powerful. They save time. They ultimately save cost and money for individuals who are using these techniques. And it looks like we have another question that I noticed from the community, and hopefully this shows on the screen here. This is a question that was asked by Juan on Quora. And the question is, are databases like MongoDB used for simulating learning machines? Are databases like MongoDB used for the simulation of machine learning? So let's backtrace here. Simulating machine learning is not necessarily something that is common. Machine learning is a tool to derive insight from data, and which means that simulation is referring to the idea that data is changing over time. And so in the context that we're describing here is that data is evolving. Perhaps we are doing simulation of COVID-19, very relevant in today's society. And the question is, how can we use machine learning to simulate data? Well, this is one part of the question. The second being, how can we use MongoDB for the data simulation? So data simulation is the context of data is evolving over time. And again, we're going back to the example of leveraging data and changing that data over time. So we're simulating how COVID is acting and how it's behaving and changing over time. MongoDB is a tool that individuals can use to store data. Now, if we think about what MongoDB is, we realize that MongoDB is a NoSQL type of a database program. Another way to think of them as a cross-platform, document-oriented database system. MongoDB uses JSON-like schema for, rather JSON-like document structure for storing data, where there's an optional schema definition. And this schema is sort of the structure behind that data. In other words, MongoDB does not force the data scientist or machine learning practitioner, or for that matter, any individual dealing with data, to structure it in any specific way. And so from the perspective of flexibility, it's a very powerful database program. But there are no competitive advantages to using MongoDB over other type of database solutions like MySQL, for example. And so MongoDB is simply a data store, right? So if we're thinking about how we can store data, Well, we can store it in any number of ways. MongoDB is one way that we can store. MySQL is another. And this sort of data store is not necessarily what we want. If we're aiming to create a better solution for applying machine learning technologies, then the goal is not just to use data. The goal is to use data with metadata or metadata. This is a concept that not many people are familiar with, but it's super critical as we scale data over time. So what is the difference between data and metadata? And how does metadata important for machine learning simulations? That is what you associate as data, whether related to an individual, whether related to a company, whether related to perhaps that individual's behavior or actions over time. So imagine we are dealing with an individual who is visiting a website, and the data that we're storing about that individual is the data that they are clicking on specific elements of the website. They are typing things, they are browsing the web, if you were. This is considered data. Metadata is slightly different. Metadata is the data that's associated with the data. So imagine we're asking the computer the question, please create a timestamp. Please let us know when the user visits a specific website, when the visitor hits a specific link. The timestamps of the data and all of the associated data is called metadata. Metadata is very important. Metadata allows machine learning models to receive even more rich data. So not just data about the individual or their behavior, but also data about when that behavior occurs and how does that behavior change over time. So metadata is very, very important. And metadata is not something that many databases are addressing today. MongoDB is unfortunately not a solution tailored to address metadata storage. If we were to think like a machine learning practitioner, we need to consider how we can store data in the most effective way and what other types of relevant data we can store. And there are other databases that are more optimized to solve this problem rather than MongoDB. So hopefully that answers your question, Juan, on Quora. MongoDB is a great NoSQL database, but it does not allow machine learning practitioners to leverage metadata, and it simply allows individuals to use data in their application. Great. Hopefully that answers your question. I know there are many questions that we can go on in this live stream, and I remind all of the audience that joins this live stream that this is an interactive live stream. I am very excited for you to join me, for you to watch. If you have a specific question about AI, about machine learning or deep learning, feel free to ask. You know, I definitely want to have this live stream be as engaging as it can be. And so while I sort of think about what is the next question, feel free to leave a quick comment and I am more than happy to address your question. Let's see what other questions we can consider here. Okay, great. And the next question will be, let's see. Oh, perfect. Hopefully this is something that brings value to you and this live stream is of use. This particular question is from Eduardo on Quora. Eduardo asks, what are some techniques to reduce training and prediction time of neural networks? keeping its accuracy and recall? This is a question that I will address, and it's related to another question, which is what are some of the ways that you can use, or rather, what the previous question was, will AI automate data science and machine learning jobs? And this question is related to that, and here's why. Eduardo, if you want to know what techniques are useful, the first place to start is to use automated machine learning. Now, I'm a big fan of this technique, of these tools. Automated ML, for short, is a very powerful set of techniques that allow to not reinvent the wheel, right? As a practitioner, you don't want to do something that's highly repetitive, highly monotonous, highly inefficient. And what you want to use is you want to use a solution like AutoML to address these types of problems, such as reducing the training and prediction time. So I'll give you 3 examples of how automated ML is useful in the context of this question. The first being, we can use AutoML to do something called a neural architecture search. The second is that we can use the hyperparameter optimization. And the third is we can use automated feature engineering. These are 3 different distinct tasks that we can solve using AutoML. And each task we can tailor to make sure we reduce the training and prediction time of our models. Hopefully, Eduardo, this answers your question. And it looks like we have another question, and the question comes from Cora. Anonymous asks, what are the advantages of natural language processing? This is an excellent question. NLP, for short, is a very, very powerful computer science area that a lot of companies are pouring billions, if not trillions of dollars into. NLP allows companies for the first time to use computational language models to understand the spoken and verbal words. NLP allows companies to extract insights from conversations, to extract insights and generate predictions based on conversations, whether they are textual, whether they are vocal, or whether they are multimodal, meaning they're using a variety of different data inputs. Language modeling is today the second biggest domain of study. NLP allows companies to create solutions that did not exist 10, 20 years ago, thanks to one key technology. And that technology is deep learning. Deep learning is a very powerful NLP application. And what it allows individuals to do is it allows individuals and companies to use supervised learning techniques and address those types of problems using deep learning in order for companies to extract insight from language. So I'll give you one example. Imagine that a company is using its social media data to make sense of where are my customers today. Are they satisfied with my product or service? Are they happy? Are they angry? Right? This is the perfect example of using NLP, or specifically solving an NLP task. In this context, we're solving the idea of text classification, if we are solving the problem of what is the category of this particular text conversation, if we're looking at a customer segment where we're analyzing the positivity score, this is an example of something called sentiment analysis. Now, each type of data problem is addressed using NLP, and it's just a matter of how you use the NLP technology to address the specific question. So, to answer your question, Anonymous, NLP is creating massive value for the world. Companies around the world are using this technology to better understand language, to better understand conversation, to extract insights from their customers. And this is very powerful because now companies can use this technology and they can develop semi-automated or even fully automated solutions. These solutions are able to help companies to give a value to their customers faster at a fraction of a cost of hiring an individual who would do the same thing one specific tweet or one specific social media post at a time. And the advantages of NLP are vast. There are companies around the world who are investing lots of money into the research and development of these algorithms. And NLP today is one of the fastest growing fields, and there are many type of applications that are applied across a variety of domains. And this is why NLP is so powerful today. And from my perspective, I would say that computer vision is the first place. NLP is second. Okay, the next question I see on the list is the question of how will a future job in AI or ML be, and what are the requirements to get it? Seth on Quora asked this question. Thanks, Seth. I shortened your name for abbreviation, but hopefully that I show you what you are looking to get from this answer. How will the future job be affected by AI technologies, and what are the requirements for individuals to make sure that they are prepared? This is my interpretation of your question. Hopefully that is correct. The question really is a matter of what is the future of AI industry look like? And unfortunately, nobody knows, right? Being in the AI field for the last 7 years, I noticed trends within the community. However, I do not hold the magic 8-ball, and I am by no means predicting the future when it comes to what does that future job look like. Having said that, I do think that I share some insights that hopefully will allow you to derive value from my answer. So future AI, future ML require expertise in two specific domains. One is information, also known as data, and the second is in biology. Both of these domains are necessary for anyone to use and apply machine learning technologies. And so the future job requires individuals who know how to leverage data and biology. Now, both are heavily influencing how deep learning, how neural networks behave. And so this idea of learning both is necessary. So the question then becomes, what is required? What is required of the individual so that they prepare themselves for the future when AI and machine learning is encroaching on their job? Well, the best preparation is offense. The best defense is offense, if you were. And short of waiting for that moment when AI will replace or automate what you are afraid of, the best thing to do is to prepare yourself for that eventuality, for that probability, and the probability that an AI system will come in and perform a specific task better than you can means that you must think about how you can prepare yourself. And the requirement is you must study math and you must study biology, and math allow you to further develop these technologies. If you wanted to better prepare yourself for this technology, I would study also computer science, artificial intelligence, machine learning, or deep learning. These are domains that are related, one being mathematics, one being computer science. These types of problems, if you study these problems, you are preparing yourself for the future state when AI comes in and changes what you consider to be a job or a task. So keep in mind that this is a moving field. There is no magic 8-ball for what it looks like in the future. But if you understand how the technology works today, then you can prepare yourself better for the future. So the short answer is study data, study math, study computer science, specifically AI, and you will be ready for when data and AI is necessary in the future. Great. What else can we address from the community? And it seems like there are other questions that we can individually pick on Quora. The question is, what are some applications of deep learning? Amy, this is one of the best questions, especially for individuals who are not well versed in this industry. Deep learning is a subset of machine learning, which is a subset of artificial intelligence. And so Amy asks, how can AI, and more specifically deep learning, be used to solve problems? What are some of the applications of this industry? Amy, I remind you, like any technology, deep learning is a tool. It can be used for good and bad, which means it is unbiased in its application. However, to answer your question, it really depends on what industry we're talking about. Are we talking about healthcare? Are we talking about transportation, aviation, right? The industry itself will often dictate the use case of deep learning. Having said that, without going specifically into the industry, I'll share with you a few examples of the applications and how they may be used across different industries. So let's consider that if we want to solve visual data problems, we're most likely going to use some computer vision algorithm. CV for short is one of the best technologies today that allows individuals to solve visual data problems, right? Whether it's a picture, like a still picture, or a moving picture like video. Computer vision domains are by far crushing the investments in the AI space today. So to answer the question, let's say we are solving a computer vision problem, and specifically, we want to know what is inside an image. What are we looking at? This is a image classification model. If we're solving this particular model, we want to use various types of algorithms, such as convolutional neural networks, which are briefly mentioned in this particular live stream. We want to use CNN to solve image classification problems. And if the goal is to address what is inside an image, then we can right away realize that this particular problem occurs across all sorts of industries, whether we're talking about from the perspective of food and beverage, addressing imagery from the perspective of security, addressing images in the healthcare space. We can use image classification, which is one particular example or task of deep learning, to solve a variety of different domain problems. So in healthcare, for example, we can leverage image classification and we can create a COVID-19 diagnosis model. This is an application of deep learning. If we're talking about the food and beverage industry, we can use image classification to detect rotten food, right? If we're looking at image classification for the security industry, we can detect malicious human behavior, right? Malicious body language. These are the different applications or use cases of how we leverage image classification, how we leverage computer vision to solve industry problems. And these particular types of problems are very, very common. And so if you have a question, like I've mentioned before, feel free to leave a comment, and I'm more than happy to address your answer during the live stream. And it looks like we can continue this particular discussion, and let's see what other question we can find. Thanks, Amy, for the previous question. The next question is by David on Quora. And the question is, does the order of training data matter when training neural networks? Thanks, David. I want to answer the question by addressing what is a neural network first. For those who are slightly unfamiliar with the term, neural network is another common synonym for deep learning. And deep learning is simply a machine learning model that has many layers. In other words, it's an algorithm that's taking in data, and in order to come up with its output, it's learning by breaking that data into multiple pieces, into multiple layers. So if we're talking about an image classification task, a layer is, for example, the shape of the image. Another layer is the form of the image. Another layer is the light intensity, light saturation, etc. So each one of the visual elements of image represents a layer, and neural network is simply the representation of an algorithm that has many layers. And the more layers, usually the deeper the neural network becomes. So the question is, does the order of training data matter when it comes to training neural networks? These terms are quite specific, so let me address another part of this particular question. For those who are listening who are not familiar with the term training data is the idea that we have two types of data. We have a training data and we have a testing data. Training data is what we need to train or teach AI algorithms what data means. And testing data is how we ask, hey, algorithm, tell us what this new data means. Training data is the data necessary to get our model up to speed, and the resulting data or the test data is what we need to ask once the model has been trained, what does this new data look like? David asks, does the order of training data matter? No, it does not, David. The order is not important. Having said that, it's very important to eliminate the issue of order by randomizing data, right? Data science is a very well established many ways to randomize data. The easiest of which a data scientist or a machine learning practitioner can write a function that with one command can randomize data and shuffle that data around so that data becomes less biased. And perhaps this is a question that I can address on a side note. Why is randomizing data important for minimizing bias? Bias is what we assume about that data and the assumptions that carry all the way through to the output of that data. You know, biases exist both in us as humans and in machine learning models. And the best thing we can do as practitioners is to minimize that bias. How do we use algorithms to minimize bias? Well, one way to do so is to randomize it. Make sure that data does not appear in any specific way, in any specific order. And by randomizing that data, by shuffling that data back and forth, we reduce the risks that are associated with having one data be connected to another data. Randomization is one. Another powerful way that is addressed is where you take the data and you compress it, you condense that data. Another way is where you expand it or explode that data into smaller components. Another great way to make sure you reduce bias is to change the data by making, for example, visual edits to that data. So if we're dealing with imagery data, we can rotate that image, we can skew it, we can change it and modify it in such a way that that transformed image looks different than the input image. So these techniques of transformation, of randomization are highly, highly recommended because they reduce the bias, the assumptions that the model makes about data, and we can create more accurate models as a result. And this is a powerful technique to be used by practitioners. Anonymous on Quora asks, how different is a TPU from GPU? So TPU is a tensor processing unit, and it's different than a graphics processing unit. So let's break down the two. Graphics processing unit, or GPU, is a term that was created to allow individuals to use data in a very unique fashion. So instead of doing calculations in a specific way, the hardware evolved over time, right? So let's backtrace here. CPUs are simply pushing data back and forth. They're doing calculations on that data, right? If data represents 0 and 1, let's consider this idea of a traditional or classical data. 0 and 1. This data needs to be calculated. The CPU, or central processing unit, kicks in. It now starts to change that data, and it starts to modify, it starts to multiply zeros and ones together, and it comes up with a result. However, when that data becomes more complex, when that data requires visual change, right? When that data changes from one state to another, for example, when a person wants to create a movie where one picture changes from one frame to the next, this is the perfect application of GPUs. GPUs were created to address graphical problems. GPUs would start or kick in when graphics were being changed visually on the interface. And so graphics were, interestingly enough, the best possible application or hardware for using deep learning. So if we backtrace and we ask ourselves, why are GPUs important? Well, the fundamental fact is that deep learning blew up. It exploded when AI, and specifically when deep learning began to leverage GPUs to solve problems. When data was stored on a traditional server or data store like MongoDB, that data needed to be processed, and processing that data required it required computational processing power. This power came from GPUs, and so deep learning models started to use GPUs to solve different types of problems. And then Google released their own version. Google, being one of the innovators of deep learning, Alphabet is now the new name for Google, realized that, well, the way that data flows inside the GPU is actually quite unique, right? Sometimes data goes forward and sometimes data goes backwards, right? In deep learning or neural networks, you have this idea of forward propagation or backward propagation, right? So when the data flows forward, the GPU is an amazing tool to solve those problems. But when the data goes backwards, as if the algorithm is learning on different types of representation between different types of layers, then the back propagation kicks in, and GPUs are slightly less efficient. So Google said, or Alphabet, hey, is there a better way to leverage computational power, hardware computational power, to solve deep learning problems? And the answer is yes, 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 you can. Google team started looking into the architecture. They realized that the hardware is actually something they control. And so they decided to create a new hardware. They call this hardware a tensor processing unit, name being inspired by TensorFlow, Google's open source deep learning framework. Tensor is a unit of TensorFlow, the framework. Tensor represents a node or a single spot within the deep learning architecture, and this is the inspiration for the name. Deep learning uses TensorFlow's tensors to create solutions. Now, Google released TensorFlow Processing Unit, TPU, in order to make deep learning faster. Let's bring our value to the audience and community. Why are we doing this, right? The context of using GPUs or TPUs is because we want to get our answers fast. We want to derive insights faster. We want to create the solution faster. We want to generate revenue faster. And most importantly, we want to reduce costs faster. If we're using TPU, we're now using a very specialized type of GPU, and TPUs allow us to get what we want at a fraction of a cost of what a GPU would take. Having said that, there are costs associated with TPUs. Like any hardware, we must invest. We must be thinking in the future, what hardware do we need today to make sure we get to that state? And so one of those investments is leveraging TPUs. Now, if we're using the cloud, Google already allows us to spin up cloud servers that use TPUs. And so if we're using the cloud, that's a great way to go about it. If we're not in the cloud, data scientist or a machine learning practitioner who works for a more traditional company, you may not have access to cloud services such as Google Cloud Platform. And the question then becomes, well, how do you use TPUs? What is the best way to get your hands on it? I would say go on Amazon, search for TPU, and buy the hardware component yourself. I'm not an affiliate of Google. I am not an affiliate of Amazon. I just love their platforms. I use both platforms. So as a side note, keep that in mind. But TPUs are an amazing way for you to use deep learning so that you are more efficient in the process. And it looks like we have the questions that I decided to answer on this live stream are now addressed. And it looks like we're coming to our end. And like I said, this is a live stream. And if you are interested and you have a question about AI, feel free to link your question. Feel free to comment on this live stream, and I'm more than happy to answer it. Now, the question then becomes, what is next, right? So, we talked about the different types of problems that can be addressed on this particular live stream. We answered different types of questions, and the question is, what is next? Well, next is I want you to join me for another session for this particular live stream. I plan to create more of these videos. And if you are interested to ask questions about AI, feel free to join and feel free to leave a comment, ask your question. The next step is for you to contact me. This is an open-ended conversation, and I want to make it super clear that I'm here for you. I'm here to give you what you want. So if you are a data scientist, machine learning practitioner, project manager, executive, decision maker, and you already have data or you already have capital, then feel free to reach out to me and schedule a brief phone call with me where we can discuss how I might be able to help you to get to your goal, right? The next step is to subscribe, right? I know that I've provided quite a bit of value here. I know that if you want to join me next time, the best way to do that is to hit the link below, hit the subscribe button, hit the like button, hit the bell, and you will join this live stream the next time I have one. I plan to schedule one shortly. And I believe that you and I are on a path. This path is allowing us to leverage data better, to get more insights, to generate revenue, and reduce costs faster. If you haven't guessed yet, this is the path of artificial intelligence. AI, or artificial intelligence, is one of the most powerful, one of the most promising, one of the most incredible technologies that people need to use today. Companies around the world are already using these technologies. So it's just a matter of time. It's just a matter of application. If you have questions about it, ask them. I know that I have a few minutes left before I decide to jump off. I want to thank Rael for bringing this particular comment to my attention. Thanks, Rael. I appreciate you sharing that you found the session useful. I want to conclude with the simple fact that AI is here. AI is revolutionary. The question is, are you using AI? Are you using it personally? Are you using AI professionally? And if you do want to leverage AI in the best possible way, then I highly encourage you to get in contact with me, schedule a brief 15-minute call, visit Produvia.com, where you can find the link to the discovery call. In this call, you and I will be able to discuss AI and machine learning. You and I will be able to discuss the different applications or use cases of this technology. And I look forward to chatting with you. I look forward to connecting with you. I'm very thankful for your time. I'm very glad you joined this live stream, and I look forward to hearing from you. Thanks very much for your time, and until next time.